What if string theory were right? Imagine asking the universe a huge question: why are there so many kinds of particles, and why does gravity seem different from the other forces? String theory is one bold answer. It says that deep down, the smallest things may not be tiny dots at all. They may be tiny vibrating strings. In this idea, each kind of vibration would look to us like a different particle. One wiggle might behave like an electron. Another might act like a quark. Yet another could carry gravity. It is a little like a violin string making different notes. The string is the same, but the sound changes when the vibration changes. If string theory were correct, it would mean the universe is built on one hidden pattern. The many pieces of nature would be different faces of the same secret structure. That would be a grand success for physics, because scientists have long wanted one theory that can describe both the very small world of particles and the very large world shaped by gravity. This would also help explain why gravity is so strange. Gravity is easy to feel when an apple falls or the moon circles Earth, but it is hard to fit into the same rulebook as electricity and magnetism. String theory tries to place gravity in that rulebook by making a particle-like vibration for it, often called the graviton. But there is a catch. A beautiful idea is not the same as a proven idea. Science needs evidence, and string theory has been very hard to test. The strings, if they exist, may be far too tiny for our best machines to see directly. Many of the theory's possible versions also make it difficult to know which one, if any, describes our universe. So if string theory were right, physics would gain a deep and elegant picture. The universe would be like a cosmic orchestra, with every particle a note played by tiny strings. We would finally have a path toward unifying all forces, including gravity. If string theory is not right, it may still have been useful. Sometimes a theory points the way to a better one. Even then, the search itself teaches scientists new math, new ideas, and new questions. For now, string theory remains a daring map without a final treasure mark. It is one of the most fascinating possibilities in modern science because it asks whether the world is not made of little balls, but of tiny songs.